Welcome. In this video, we're going to talk about interval notation. Interval notation is used whenever we are dealing with inequalities. So inequalities are always expressed using interval notation. So what is an inequality? Well, inequality symbols could be greater than, could be less than, greater than or equal to, less than or equal to, and then not equal to. So all of these represent an inequality symbol, and whenever we have something with an inequality symbol, we're going to need to remember to use interval notation. If we are dealing with strictly a less than or a greater than symbol without the equal to, in those situations, we call this an open interval and we use parentheses. Sometimes when graphing on number lines, you may see an open dot. An open dot is the same as a parenthesis. It says we're getting infinitely close to something, but not touching it. And when we're dealing with parentheses, we call this an open interval. So not equal to, we have this open interval. If we're dealing with equal to, we would use brackets. Another way you might see that bracket indicated would be a closed dot. So brackets are going to indicate a closed or a finite interval. So I've mentioned that word infinity. Well, infinity is a concept. It's not a number. Infinity does not exist because if you think of the very biggest number you can, you could always add one to it and poof, there would be a new bigger number. So since infinity doesn't exist, it's only a concept, you cannot you can't be equal to something that doesn't exist. You can't touch something that doesn't exist. And for that reason, we always use a parenthesis with infinity because a parenthesis means we don't have that equal to symbol. We're not touching. We also have here a union symbol, and you will see this union symbol. It's kind of like a U, but more of a cup. All right, so you'll see this union symbol show up. You'll need to use the union symbol a lot. When we read the union symbol, we read that as the word or. So before we talk more about that, let's notice we have an intersection symbol. An intersection symbol looks kind of like an N. A union symbol looks kind of like a U, right? So we've got union and intersection, and they're the same, but they're different. So intersection reads as the word and. So I have two other things to note. We have an element symbol, and you will not be needing to type this or use this in your homework. I personally prefer to use the element symbol because it lets us know, or it's kind of like writing a sentence to say, hey, this is what my answer is, rather than just giving some random numbers. So it gives context to what we're writing. And the element symbol means that something is an element or a member of the set. So if I wrote X element, that would read X is a member or belongs in the set, and then I would write my set over here using interval notation. And then the last thing, which is very, very important, we always want to make sure that when we are writing our intervals, we are traveling least to greatest, left to right. So least to greatest, left to right. If you write your interval in the wrong order, even though I may know what you mean, you are going to be counted wrong. So we always go least to greatest, left to right. And for that reason, I'm going to show you, ways to develop your intervals. Maybe drawing a number line first can really help you. All right, now let's circle back around to the idea of union versus intersection. Here I have drawn a Venn diagram, which is essentially two sets overlapping. Adding some color and some labels, we could think about this red circle as representing set A and the blue circle is representing set B. And we could think about A and B, A being the set of numbers 1, 3, 5, 7, and 8, B representing the set of numbers 1, 4, 5, and 9. So let's really delve into the difference between union versus intersection. What would be the union of these sets? A union B. Well, the union means that these values are either in set A or in set B, right? So union being or, that means it's all of the numbers. So A union B would be 1, 3, 4, 5, 7, 8, and 9. I believe I wrote all of the numbers that are in my two sets. So contrasting that, what would be the intersection? A intersect B. So the intersection, those are the numbers that are in both sets. It has to be in set A and in set B. And you can see here we've got this region in the center where the two sets are intersecting. So the intersection of the two sets is only the values 1 and 5. And you are not specifically going to need to do all of this, but I think it's really important to distinguish early on the difference between reading something with the word or, union symbol, versus and, which would be the intersection of two sets. So we will be using and drawing the union symbol a lot to say, hey, it's in this set or another set, but we won't use this intersection symbol at all. The concept of and having to be true in two statements at the same time, statement A and statement B, will occur. Okay? So let's look at some examples of writing an inequality in interval notation. So we're going to write each of these. We have 4 inequalities here in interval notation, and we're going to graph each inequality on a number line to help us make sense of what we are looking at. So example 1, we read this as x is greater than or equal to 3. When we see the symbol greater than or equal to, that means we need to go to the right of 3. That means we're shading to the right of 3. Now, since it has an equal to, we can use a square bracket here to indicate we are including that. You may have seen before in a previous math class using a closed dot. This is the same idea. Okay, so if we were to write our solution set, that would be that we have 3 included, and as we travel to the right forever, those numbers are getting larger forever, we are approaching positive infinity. We write our infinity symbol, and even though we use a bracket on the left, we must use a parenthesis, which indicates we are not touching it on the right. So this would be our answer here, 3 to infinity. Now, I'm inclined to say x is in the set from 3 to infinity. You do not need to write x as an element of the set, x belongs in the set. You don't need to write that in your homework. All right, let's move on to our second example, which is an interval written in conjunction. So this is kind of like the and situation. This is a conjunction. And essentially what this says is we have 2 statements. We have that x is greater than or equal to 2, negative 2. That reads as negative 2 is less than or equal to x, or rather, x is greater than or equal to negative 2. When you reverse the way we read that, the alligator is going to turn around and follow the bigger number, right? It still means the same thing this way. Negative 2 is less than or equal to x. X is greater than or equal to negative 2. And you'll notice x is also in this set. This says x must be less than 5. So both of these statements have to be true at the same time. X has to be greater than or equal to -2, and x has to be less than 5. So let me plot my numbers on my number line. I have -2 and 5. Greater than or equal to -2 means I draw a bracket because of the equal, and then I move to the right, greater, because of our inequality symbol, and then x being less than 5. Less than 5, we draw a parenthesis, and then we travel to the left to go less than 5. So in this situation, my solution set is where x is in both of these intervals simultaneously. So the solution here is x is in the set from -2 to +5. And we draw a bracket at -2 since we can be equal to that, and a parenthesis at 5 because we cannot touch that. All right, let's look at an or situation. Technically, this is called disjunction. So here I have the situation where x is greater than 2 or x is less than or equal to 0. So I'll mark 0 and 2 on my number line. Greater than 2 is a parenthesis at 2, greater than, we shade to the right. And less than or equal 0, that means we have a bracket at 0, and less than, we shade to the left. In this situation, my solution set is that x is in the set from -infinity with a parenthesis to 0 with a bracket, union 2 with a parenthesis to infinity with a parenthesis. So remember, as we travel to the left and to the right forever, we're approaching negative or positive infinity. So this would be the correct answer that you would need to be able to infer from that inequality. And then our last example here, example 4, we're given the inequality x is not equal to -4. We have to think about what it means for something to be not equal. Well, if it's not equal to -4, that means x is less than -4 or x is greater than -4. So let's graph this. Here is -4 on my number line. Less than -4 is right at just touching -4 and shading to the left. And greater than, we draw a parenthesis right at -4 and we shade to the right. Now, technically these two parentheses would be a lot closer, but I'm leaving that gap for emphasis. So in this situation, x is in the set. The set on the left is -infinity to -4. Union, the set on the right, is -4 to +infinity. So there we have 4 different situations where we can take an inequality statement and write that in interval notation. Now, I do like to think about this extension here, which is what if we changed example 2 to read or versus changing example 3 to read and. So you see we had and or. We're going to change that to or and look at what that does to our intervals. So let me write that down here. So for example 2, we had x is greater than or equal to -2 and x is less than 5. I'm going to take that and, we'll cross that out, and we're going to change that to read or. What would that look like if we tried to shade and graph that? So -2 and 5, greater than or equal to -2, we're shading to the right, less than 5, we shade to the left of 5. So since this is or, which regions represent a solution? Or is the union or all of this region? So if that had been in disjunction and we'd had or written there, the solution set would be all real numbers. It'd be negative infinity to positive infinity, because regardless of where I choose that value, it will work in one statement or the other. Similarly, what we had for example 3 was x is greater than 2 or x is less than or equal to 0. And here we're asked to take that or statement and to rewrite it with and. So if we'd had this with an and here, x being greater than 2 and x less than or equal to 0, what does that look like? Well, where is x greater than 2 and less than or equal to 0 simultaneously? So greater than 2, that means we shade to the right of 2, and less than or equal to 0, we shade to the left of 0. So where can I pick a number on this number line that will work in both of these sets at the same time, that works in the orange and the green region? And is there a point on these lines that would be in both the orange and green simultaneously? And the answer is no. In this situation, there would be an empty set as our solution. All right, so that's kind of a further extension into thinking about these interval notations and really stressing the difference between the and concept versus the or concept. Now, interval notation is hugely important. You are going to be asked questions about interval notation or writing something in interval notation on every test. I encourage you, if you have any questions or concerns, please email me, get in touch with me right now so that we can talk more about this. Okay, so the idea here is, how do we write these different inequalities using this new interval notation? Good luck out there.